In this video, we are going to be talking about data type conversion. And with data type conversion, we're going to be talking about dynamically typed languages versus strongly typed languages, as well as coercion, which is implicit or explicit type conversion. Now, we'll get into exactly what each of those mean as we get through this video. So let's start out with dynamically typed languages versus strongly typed languages. Now, there are two schools of thoughts in programming. There is the thought that every variable used in a program should have its type set explicitly. Now, what this means is that when I'm defining a variable that's going to hold a string, I need to make sure that everybody in the world knows that that variable or that container is going to hold strings and only strings. And so in languages like C# and Java, when you declare a variable, you're going to see something like this: string and first name equals Bob. Now, if we go through this in a little more detail, string is the data type. This is the variable name, or the pointer to the memory location that we're going to get back from the operating system where the data Bob, that string, is going to be stored. And in a strongly typed language, the string says that any value that gets stored in this variable has to be of type string. And so if we were to go back and change the string Bob to the integer 123 and it were to execute, what would happen in a strongly typed language is before it ever compiled, before it ever executed, we would get a compile time error, meaning that our IDE, when we went to run the program and we compiled it, it would identify that we are trying to stick an integer, 123, into a variable first name that is strictly set up to only hold strings, and our program would not be allowed to execute by the interpreter. Now, what this does is, the thought is that it reduces a lot of runtime errors in that developers cannot accidentally put the wrong data type into the wrong variable and then use that data type in a way that is not or does not conform to the data type that is being held by that variable. Now, that can be really good because you can catch a lot of runtime errors prior to executing your application, which can save some time. So there's nothing wrong with this approach. The other school of thought is that the executing environment for the programming language that you're using, it should really actually be smart enough to determine what the current data type is being held in a variable and allow the user or the programmer to operate against that data type in whatever they want, as long as it conforms to the current type that is being held in that variable. So to make this more clear, here I have let first name, and I'm going to say Bob, and we better capitalize that, it's a name. I'm going to say Bob, and if we call up first name, we're going to see that the value is Bob and it is a string. And so if we wanted to, we could take first name and we could do anything on it that we can do on a string. So right here you'll see a list of different functions that we can do on a string data type. All right, so we could pick any of these. We could say to uppercase, and we could execute that function against it, and we could, let's store it back in itself. And then we see that now Bob is all uppercase. So every single letter in that sequence of characters are all uppercase now instead of just the first letter. So there, we executed a function that belongs to the string data type against a string that was held in that variable. Now, the problem that a lot of people have, and the runtime errors that can happen in a dynamically typed language like JavaScript, is because variables are not strictly set with their data type, instead they are dynamically allocated, their type, is that we could actually take first name and we could actually add a number to it and completely replace the string Bob inside of that variable. So here, first name now holds the value 123 instead of the string Bob. Now, that can cause some problems at runtime. If in our program we have an error in our code where it allows perhaps the age to get set against the first name, we could run into some problems because we're expecting that variable to be the first name of the person we're operating on, but instead it holds their age because of a program mistake that we made as a software developer. And then later on in the code, if we try to run the exact same thing, first name dot to uppercase against the code, we're going to get a runtime error. In other words, our script is going to explode, our program is going to stop running, and that is because we're trying to do an operation against a data type that does not have that operation available to it. So you cannot change a number to an uppercase because numbers do not have uppercases, only strings do, only characters do. So here we could run into a runtime error if we're not careful as programmers. So there are some advantages and disadvantages to strongly typed languages and dynamically typed languages. Strongly typed languages have the advantage of runtime errors being caught before the application ever runs when the code is compiled by the IDE before it ever gets run. So we can catch a lot of errors at the start. But it restricts a programmer's ability to have more flexible code because you can't use a variable to hold different data types if you're trying to be super flexible in your programming style, or if you need to be able to be flexible because you don't know what data type you're going to get back from, let's say, a third-party web service, an API or a library, or from the internet itself if you're extracting stuff off of a page. So, you know, there's advantages and disadvantages. So a dynamic language or dynamically typed language may allow you to be a lot more flexible as to what goes into a variable, but at the same time, you may end up with a lot more runtime errors and bugs that are hard to figure out. So the reality is that there are advantages and disadvantages to both, and depending upon what you are trying to accomplish when you are programming, it is up to you as the developer or the software architect to decide whether to use a dynamically typed language or to use a strongly typed language. Which one gives you the most benefit for the objective that you are trying to accomplish? So I prefer not to be biased one side or the other. I choose the language that is best for the project that I'm working on. I've worked in C#, I've worked in PHP, I've worked in Java, I've worked in Ruby, I've worked in Objective-C, I've worked in JavaScript. So it all depends on the project that you're working on and what you're trying to accomplish as to whether or not you choose a dynamically typed language or a strongly typed language. So understanding strongly typed and dynamically typed languages, this allows us to better understand JavaScript and where we're at when it comes to type conversions. So let's go over type conversions. JavaScript allows implicit type conversion. So implicit means that you as the programmer are not specifically stating how you want to convert one data type to another. So let's use an example here. So I have a string. So let's say let first name equal Fred. And let's say, oh, I've already got first name defined. So say, let's just use first name. So first name equals Fred. So I just changed it to Fred because if you notice, we defined first name up here with the let keyword. And the let keyword will not allow a variable with the same name to be redefined later on in the same script. So here I tried to take first name, which had already been defined up here and already been allocated the term, the string Bob down here, and so it threw a fit. So I already have first name, so let's just reassign it to Fred. And then let's come last name, let's introduce last name to it, Fred Flintstone. Okay, So now we've got first name and last name as strings. And so if we wanted to perform an operation on these two strings, we could go ahead and say let full name equal first name plus, let's add a space in there, last name. And if we call back full name, we will see that we get Fred Flintstone. Now, where conversion happens, or implicit conversion of a data type, is when we have two different variables with different data types in them, and we try to perform an operation on those two together, and one data type has to be coerced or changed into another data type for the operation to be successful and not throw an error. An example of this is taking a string and a number and trying to combine them together. So let's add age. Well, let's see, Fred Flintstone's probably about 2,000 years old by now. So we've got Fred Flintstone, age 2,000, and if we tried to combine the full name, actually let's store this in a variable. So let profile description equal full name plus another string plus age, and we hit enter. Now once that executes, we'll see that we get back a string that holds Fred Flintstone 2000. Now in this particular operation, when that statement was executed, what happened here is age, which is an integer, it's a number data type, and then we've got two strings that are getting added to it. JavaScript will automatically take a number when we are using the addition operator with strings, and it will implicitly, or behind the scenes on its own, take the number and convert it to a string before it adds it to the other strings, because it has been written with the understanding that if we are trying to add a number or a boolean or anything to a string, we really want a string in return. So the designers of JavaScript have decided that that is the way it should be, that most often than not, when we add a number to a string, we really just want a string back. And in reality, that's most of the time completely accurate. Most of the time when we are adding some other data type to a string, we are really creating it for user output, and it really should be a string for readability. So what happened is age was implicitly converted from a number to its string format, and then it was added to the two strings, and we get a single string back. So that is implicit conversion. JavaScript doing the data conversion from one type to another for us behind the scenes. And we could go the other direction too, and we would run into the exact same situation. So let age profile equal age plus a space plus full name, and let's see what we get back. We get back the same thing. We get back a string. This time age is in the front based on our order of operation when we added everything together, and we end up with a string. Now this gets a little bit more complex when we try to add a number in the form of a number to a string number. So here, let's jump into that. Let compound value equal, and let's go with the number 50, but in its string format. And then let's go ahead and add to it a number that is not in its string format. So let's do 100. Let's see what we get back. You'll see right here, we get an implicit conversion that you may or may not expect. Based on our discussion earlier about the strings, it should be expected. We're taking a compound value, we're taking a string, and we are adding to it a number. And as we already discussed, Java has been written in order to take a number, implicitly convert it to a string format, and then add it to another string. So we should actually expect to get this based on what we've seen before. Where it gets kind of strange is the plus character when you're operating on strings creates a string. But if we use a different arithmetic operator, such as the minus operator, we get a different result. And so this is just something you'll need to learn, that JavaScript handles the minus operator when dealing with strings and numbers differently than it does when it uses the plus operator. So let's see an example of that. Let minus number equal, and we'll do the same thing. We'll do a string 50, and we will minus 100 from it. And let's see what we get. We get a negative 50. So unlike using the plus operator, where the number is converted to a string and added to the string, and we get back a compound string, instead, when we use the minus operator, the designers of JavaScript decided that when we are using the subtraction operator with a string and a number, they decided that we are going to implicitly convert the string to a number and then subtract the two numbers from one another and provide the results of that. So in this case, JavaScript implicitly took the 50, parsed it out of the string, and created a number, and then subtracted 50 from the negative 100, or from the 100, which gave us a negative 50. So keep that in mind. Plus operator with a string and another value ends up in a string. If you use the subtraction operator from a string and a number, you will get back a number. Now what happens if we try to do the exact same thing? Let minus error equal, I've got some characters in there plus a number, and I try to subtract it from 100. So if you can guess, go ahead and try to guess what's going to happen. We get back nan. Now nan, what it stands for in JavaScript is not a number. In other words, JavaScript tried to take that string, it tried to parse it into a number because we're using the minus operator, the subtraction operator, and we're using another number. So based on the underlying implementation of this, it should take that string and convert it to a number in order to subtract it from the other number. In this case, it could not extract a number from that string because the string had a whole bunch of characters in it, making it a string, not a number. So JavaScript could not implicitly pull a number out of that string. Therefore, it tried to subtract a string from 100, and you can't do that because it does not result in a number. So subtracting the string from 100 ended up with not a number. So we get back that value, not a number, and if we tried to do other operations, mathematical operations on that, we would end up with errors because we have not a number as the value. All right. What happens if you do want to pull out a number from a string before you do operations on it? In other words, you want to explicitly convert from one type to another. JavaScript provides us some global functions to do that. So let string number equal 50. And right now, if we do string number, we've got the number in string format. Now, if we want to explicitly convert that from a string to an integer, we can use the JavaScript provided function Parse Int. So let's go ahead and do that really quick. So let my number, it's not going to be a string anymore, equal Parse Int. And then let's go ahead and pass it string number. And then let's go ahead and see what my number has in it. It now has the number 50 as a number, not a string. Now, one thing you're going to need to watch out for is Parse Int. Does it work on strings that have characters and numbers in it? In other words, can you take a particular string, so let's change string number to be 50, but let's put a bunch of characters in it. And then let's try to do Parse Int on it again. Of course, we've already defined my number, so we'll need to get rid of let and just reuse it. And let's say my number. And it looks like we got back a 50 because it parsed the 50 out of that. So let's go ahead and let's change the order of the strings. Let's put 50 at the end. And then let's try to parse it again. And now we've got not a number. So when we are parsing a string, you will notice that JavaScript, if there is a number at the beginning of the string, it will stop after it's parsed all the numbers out of the string that are consecutive, and then it will discard the rest of the string and give you back a number. If at the beginning of the string JavaScript cannot identify any digits, it will throw the whole string away and tell you it's not a number. So that's something to watch out for when you're dealing with converting from a string to a number in JavaScript. And when you're getting values from JSON or from a web service or from a third-party API and you're unsure as to what those contain, or if it all comes back as strings, you'll need to make sure you watch out for how this explicit and implicit conversion happens and how coercion works inside of JavaScript.